Module 1, Lesson 10, the structure of ratio tables, additive and multiplicative. So in the last lesson, we were working on ratio tables. Now we're going to be taking a look more at how are the ratio tables actually put together. So last time we made them, we just kind of focused on the multiplicative relationships. But now we're going to look at some of the patterns within the table. And this is an exploratory activity, so it's probably better for you to look through and do this activity on your own before you sit and watch kind of some of the things that I notice. All right, learning targets. Make comparisons with and within wholes using ratio language and symbols. Reason about comparisons. Make predictions about what would happen if part of the ratio changes. We are continuing to look at these two learning targets. We'll get into unit rates and rates in a later lesson. I can statements. So I can identify the parts of a ratio table that are additive. So after we have been through this activity, hopefully you can examine a ratio table and see some additive relationships, meaning there's some adding and subtracting going on. More importantly, being able to identify the parts of a ratio table that are multiplicative. Ratios are really about multiplicative relationships. So even though there may be an additive relationship in the table, that is not as important as recognizing where the multiplicative relationship is. But we would like you to be able to use some additive and multiplicative patterns to be able to add things to the ratio table, and then using ratio tables to solve problems. All right, so the exploratory challenge is about fruit salad. And you are going to imagine you're making a fruit salad, and for every quart of blueberries you add, you would like to put in 3 quarts of strawberries. Now my brain just screamed at me, ratio. Create 3 ratio tables that show the amounts of blueberries and strawberries you would use if you needed to make fruit salad for greater numbers of people. And then we have 3 sets of instructions here. So each table is going to be a little bit different, and it's important that we pay attention to the directions for these tables. Table 1, we are going to have fewer than 10 quarts of blueberries. So in table 1, all of my numbers for blueberries have to be less than 10. So I'm going to take care of table 1 here. And table 1, I'm going to say, what about 1 quart of blueberries? And if I had 1 quart of blueberries, I see that I would have 3 quarts of strawberries. And then I say, okay, so what if I had 2 quarts of blueberries? I would have 6 quarts of strawberries. And if I had 3 quarts of blueberries, I would say that I have 9 quarts of strawberries. And of course, in your table, in your workbook, you've probably got a few more rows there. I kind of ran out of space here. All right, table 2. Table 2, I should have amounts between and including 10 and 50. Between and including 10 and 50. Now it says that I should include 10 and 50, so I should have 10 and 50 on my chart. So if I had 10 quarts of blueberries, I would know that I have 30 quarts of strawberries, because the constant we're using here is 3. We're multiplying by 3 as we go this way. I'm going to double the number of blueberries and have 60, and I'm going to triple and have 90. And if I could keep going, I would have 40 and I would have 50. Now, I could pick some oddball numbers. I could pick a 15, I could pick a 25, I could pick a 36. But for this activity, it's probably a little bit easier to answer some of the questions and to see some of the patterns if we keep the numbers simple. So I'm going to work with multiples of 1, 2, 3, 4, 5 here, and I've got 10, 20, 30, 40, 50 over here. If I want to extend my thinking, I could add some rows to the table down below. But right now I'm going to keep it simple. All right, table 3 should have amounts of blueberries greater than or equal to 100 quarts. So I'm going to start with 100 quarts and say that there are 300 quarts of strawberry, 200 quarts, and that would give me 600. and 300, which would give me 900. It's really important that I pay attention to the information given right here. Really important. All right, so I've got my table completed. Now I would imagine they're going to have me use these tables to answer some questions. All right, and I'm going to go back and fill my tables in again. I really ought to fix these slides so I don't have to do that. A future project that might happen in about 30 minutes. All right, so I've got 3, 6, 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15, 30, 60, 90, 120, 150, 300, 900, 1200, and 1500. Okay. Now, I'm supposed to look and say, are there any patterns that I see in the tables? Well, I already pointed one out on the last slide. We have a multiplicative relationship happening where times 3. So to go from the blueberries to the strawberries is times 3. And that is true on all 3 tables. Times 3 and a times 3. Now another pattern that I see, and this may be less obvious, but going back this way is a multiply by 1/3. So I notice that I have moving from blueberries to strawberries is times 3. And this actually goes back to the value stuff that we worked on a few lessons ago, that the value of this ratio here, that the quarts of strawberries are 3 times the quarts of blueberries, and the quarts of blueberries are 1/3 the quarts of strawberries. Remember, we found the value, wrote it as a fraction. So that's where these numbers, 1/3 and 3, come from, is I'm actually looking at the value of these ratios that we have built. Now, it's very possible that you will look and say, I've got times 2, times 3, times 4, and times 5. Now, let me try and a little crowded here. There we go. There's a times 2, times 3, times 4, and a times 5. And interestingly, I have the exact same pattern over here. Times 2, times 3, times 4, and my times 5. So I have some multiplicative patterns going on, and that's true in all 3 tables. So I've got multiplication going column to column, and I have multiplication going row to row. Column to column is this way, and row to row we're headed down this way. Now there is a relationship kind of between the tables themselves that would be kind of fun to look at, I guess. This table, table 1, if I multiply the values by 10, I get table 2. And if I take table 2 and multiply it by 10, I get table 3. And table 1 to table 3 is a times 100. And the same is true going the other way. I've got a relationship of multiplying by 1/10, and then multiplying by 1/10 again. And of course, I have a multiplying by 1/100th. So some interesting relationships between the tables there. I notice in this, so let's see, making sure I haven't missed any of the important ones here. Okay, so those are a bunch of multiplicative relationships. There are some additive ones that you probably notice here. Here I'm doing +1. And over here I'm doing +3. And here, of course, is +10. And over here we are doing a +30. And over here we've got a +100. And here we're doing a +300. So there are some additive relationships there. Some patterns. Now there's another one that kind of stands out to me. It's a little bit deeper, but I think it's really cool. I noticed that if I add 2 + 3 right here, that I get 5. And I noticed that if I add 6 + 9, I get the 15. So there's a really powerful additive relationship within my ratio table. And of course, in my head, I have a little hypothesis now. I've got an idea, a little theory. So I wonder if I can do that for all of them, or if that's just something special about 5s. For example, if I add the 4 and 5 together and get 9, and I add the 12 and 15 together and get 27, do I still have my ratio relationship? And the answer is yes, I do. The 27 is 3 times the 9. So there's some additive relationships within these tables also. Now, some of the additive relationships are more useful and some of them are less useful. All right, so going to move on in the exploratory challenge here. And it says, how are the amounts of blueberries and strawberries related to each other? Well, I've already pointed this out, but the strawberries are triple times 3 times the amount of strawberries. And the strawberries are 1/3 the amount, the blueberries are 1/3 the amount of the strawberries. And I already talked about that on the last slide. And that is true on all 3 tables, that relationship, that times 3 and that 1/3. So the values in the blueberry columns, how are they related to each other? So now looking down just the columns of the blueberries. And I already pointed out to you these patterns also. There is a multiplicative relationship of a times 2, a times 3, the times 4, and the times 5. That is the more important relationship. Yes, you can look and say that we are doing +1. But that is a much, much, much less important relationship when it comes to using ratio tables. The power of ratio tables comes in multiplicative relationships. So the values in the blueberry columns, they're related to each other because they are multiples of what we start with. And really, they all come back to this 1-to-3 relationship that we have over in Table 1. Strawberries. The strawberries, yes, they have this multiplicative relationship also. Ooh, I said multiplicative, and I'm writing addition. Wow. All right, so a times 2, a times 3, a times 4, a times 5. A times 2, times 3, times 4, times 5. Now, I'm going to try and illustrate on this particular slide why that adding is not as powerful and as useful. So over here, I've got +3, +3, +3, and +3. But when I come over to Table 2, and I've got 30, 60, 90, 120, and 150, am I adding 3 anymore? No, now I'm adding 30. Is that relationship the same in all 3 tables? Am I adding +3 in every single table? And the answer is no. I'm not. When we're looking at the patterns within the tables, we are looking for the patterns that are true in all of the tables, not just some of them. That's where the power comes in. So the additive relationship of just saying that we're adding 1 over here, well, that's not true over here where it's plus 10, or over here where it's plus 100. What is true is that we have a multiplicative, times 2, times 3, times 4, times 5. That multiplicative relationship is holding true in all of our ratio tables, that we have a multiplicative relationship. All right, so if we want to add 7 quarts of blueberries to the fruit salad in table 1, my table stops at 5. How could I figure out how many strawberries to add if I wanted to have 7 quarts of strawberries? Oh, sorry, 7 quarts of blueberries. Right here. It's good to read it. 7 quarts of blueberries. Now, I already showed you one possible trick. It's not a trick, one cool mathematical thing. I could combine the 3 and 4 here and the 9 and 12 here, and I would have 7 and 21. So for 7 quarts of blueberries, I would need 21 quarts of strawberries. That's one way I could do it. Now, another way I could do it. I could take the 1, and I could multiply by 7 and get 7. And I could take the 3 and multiply by 7, and I would get 7 and 21. So I can use the multiplicative relationship within these columns, coming down this way. That would be another way. A third way that I could do this would be to use the multiplicative relationship going this way. I could have 7 quarts of blueberries, multiply it times 3, and get 21. So there are 3 different strategies that I could use to figure out the 7 quarts. I can use multiplication vertically. I could use multiplication horizontally. And I can use an additive relationship for combining. So I've got 3 different strategies that I could use, add things to my table. Each of them works slightly differently, but they're all based off of good mathematical thinking. All right, so if we know we used 70 quarts of blueberries to make our salad, how can we use a ratio table to find out how many quarts of strawberries were needed? So now we've got 70 quarts. Now, we added, and I'm going to write this up here at the top. I know it's not in order, but I'm going to put 7 and 21 in here. Now, we could go over to table 2, and we could repeat the same process. We could multiply by 7 and get 70, and multiply by 7 and get 210. And we could take 70, and we could multiply it by 3, and we could get 210. And I could combine 30 and 40 and 90 and 120, and I could get 210. Or I could also step back and say, I want to use my knowledge of the connection between these 2 tables. We know that table 2 is times 10 of table 1. So I could take my 7 right here, multiply it by 10 and get 70, and my 21 and multiply it by 10 and get 210. So now I've got a 4th relationship that I could use. I've got the 2 multiplication relationships going vertically and horizontally, but I also have a multiplication relationship between the tables of times 10. And I also have my additive relationship of being able to add and combine parts within the table. All right, so that kind of concludes the exploratory activity, and now we're going to do a little analysis of some tables here. So we've got some tables. They were made incorrectly, and we're going to find some mistakes that were made, and we're going to create a correct ratio table. And then we are going to find the ratio, capital letters, the ratio that was used. So we're going to find the ratio value for the table. All right, so I need to analyze the pattern. So I've got a 3 times 24, sorry, a 3 reaching 24, that's a times 8. And I've got a 5 times 40, which is a times 8. And I've got a 7 times 52, which I'm not sure what that is. And I've got 9 times 79 to 72, which is a times 8. So notice when I analyzed this table, the first relationship I looked at was this relationship, this horizontal, because that is the very heart of a ratio relationship, is the comparison between the parts. The most important part of any ratio relationship is the comparison between part A and part B. So I'm analyzing and looking between these, and I notice that I've got 3 of them that are times 8s, but this one, boy, I don't think 7 times 8 is 52. So I'm going to come over here and I'm going to say I like the 3 and the 24, and I like the 5 and the 40. The 7 I think should go with 56. 7 times 8 is 56. And then I've got 9 and 72. Now, the other thing I have to do here is I have to find the ratio value for the table. So I need to write it in the largest possible units. And I'm looking at the 3 and the 24 here, and I'm asking myself, is there anything that I can divide both of these by? Can I do some kind of grouping? And I notice that both of them are divisible by 3. So I've got 3 24ths, and I can divide both of them by 3, and that will give me 1/8. So the ratio value here is 1/8, and I can write that as the ratio of 1 to 8. And every ratio on my table has that value, which means they are equivalent. They all have this value right here. All right, exercise 1B. So I'm going to look here. This is a times 5, and this is a times 2, and this is a times, wow, not sure what that is. And here is a, not sure what that is either. Wow. So I'm having a really hard time looking at this and saying, what ratio were they using? It's kind of all over the place. Now I see that they have done a +3 all the way down. But the problem is ratios aren't additive relationships. They're multiplicative relationships. So I'm looking at this table and thinking that they didn't really make ratios at all. So I've got a lot of latitude in correcting this. I'm just going to use the 5. I'm going to start with this first one here and say I'm going to multiply by 5. That's going to be my relationship. So I've got 4 times 5 is 20. I've got 7 times 5 is 35. And I've got 10 times 5, which is 50. I could look at the second row and say it's a times 2 relationship. But I'm just going to work with that first row. So the value here, the ratio value is 1/5. And the ratio for the table, of course, is 1/5. Now, your table may look differently depending on which of these you decide to work with. One of the big ideas on this exercise is that you notice just because they added 3 in both columns does not mean they have a ratio relationship. Additive relationships do not always lead to ratio relationships. All right, so in a vertically oriented ratio table, one looks more like this. How are the values across the rows related? So what happens as we go this way? Pretty sure that's what they mean, across the rows. Okay, across the rows. So across the rows, we get a ratio of A to B. So I'm going to put a little table here. I've got A to B. So when we go across the rows, we get a ratio of A to B. And the value of the second column is determined. So to find out what B is, I multiply this first column. I take A and I multiply it by B divided by A. And this gets back into the ratio value from a few lessons ago. So if you need to, step back into that and check that out. Well, if A is 1 and B is 2, then I would find A, the value of the second, I would find B. So 2 is equal to 2 divided by 1. E is 2 over 1, the value of A. So if A were 3, and let's do something that's going to give us a little bit nicer number. So if A is 4 and B is 8, then B is double A. So B is 8, and that is equal to 4 times 2 over 1. Double. And the first column is going to be determined by multiplying the value in the second column by A over B. So if I've got, put my table back, I shouldn't have erased it, A to B, and say this is 4 and this is 8. So to find 4, I know that that is B, which is 8. The value of the first column would be determined by multiplying the value in the second column, B, 8, by 4 over 8. Multiply it by half. The first column is half of the second column. And I know that that's somewhat confusing, but go back and look at that lesson on ratio value and it will make more sense. Hopefully you remember we did that. All right, in a vertically oriented table, how are the values related as we move down a column? So now we're looking and saying, what kind of relationship do we have as we go down this way? Well, that depends on how the table was created. They could be increasing by the same sum or by the same multiple. So in other words, we're adding, as we looked at in the examples for the exploratory activity, we added 1 every time, or we added 10, we added 30. But I emphasized that what we really want to see is a multiplicative relationship there. For example, the values in the first column could be increasing by 5, so the values could go from 6, 11, 16, 21, 26, or the numbers could be formed by multiplying. In other words, the values could go from 6 to 12, 24, 48 if the values were multiplied by 2 each time. And is there a way to use addition to figure out the next row in a ratio table? We can use the ratio to help use addition to get the next row. For example, if the ratio of A to B is 2 to 5, I could add 2 to the value in the first column and add 5 to the value in the second column. So it is possible to use addition. So we've got A to B, 2 to 5. So over here, I can add 2 because we're counting by 2s, and over here I add by 5. And I would get 4 to 10. All right, multiplication. If we use multiplication to get to the next row on the table, we need to multiply both the values in the first column and the values in the second column by the same number. So I've got A to B, 5 to 4, multiply by 3, multiply by 3, and I've got 15 to 12. Okay, so summary. Ratio tables are constructed in a special way. Not every table is a ratio table. Values will be equivalent to the same ratio. So right here, and I already hit this really hard, we have the pairs as the ratios. So this would be A and this would be B. And if it were a horizontal table, this is A, this is B. and all of them must be equivalent to each other. We do have repeated addition and multiplication that we can use. So here we've got multiplication going across from A to B. But we can also have multiplication going down the columns. Notice in this column we're counting by 3s, this column we're counting by 12s. All right, so this is kind of almost a brain-busting lesson, but not really. So hopefully you can look at the parts of a table that are additive, and you can see how addition is useful within a ratio table. And hopefully you will all make misconceptions about when you can add. Hopefully you can look at a ratio table and you can see the powerful multiplication that's happening. And hopefully you can use the correct additive relationships and patterns and the multiplicative pattern to add increase. And then hopefully you can use your tables and look and see how to solve problems. So looking at the learning targets here, make comparisons with and within wholes. So we were writing ratios to represent some situations. And hopefully you notice that these tables are all about equivalent ratios, which is what our third learning target is all about. All right, so take some time, explore some ratio tables, look at your problem set. If you've got questions, make sure you talk to your teacher. Emphasize again, step back a couple of lessons and look at the lesson on the value of a ratio. I'm pretty sure that was the one where we had the peanut butter questions. And that concludes this lesson.